Hello everyone, Global Vision with you, and today we open our course about antennas and we will talk about collinear antennas. It's simple traveling waves antennas, like a spiral antenna, like Wi-Fi antennas. Let's take a look at them. It's a really simple antenna and we will describe it in very simple way.
A collinear antenna array is an array of dipole antennas mounted in such a manner that the corresponding elements of each antenna are parallel and collinear, that is, they are located along a common line or axis. Collinear arrays of dipoles are high-gain omnidirectional antennas. A dipole has an omnidirectional radiation pattern when in free space. It radiates equal radio power in all azimuthal directions perpendicular to the antenna, with the signal strength dropping to zero on the antenna axis. The purpose of stacking multiple dipoles in a vertical collinear array is to increase the power radiated in horizontal directions and reduce the power radiated into the sky or down toward the Earth, where it is wasted. They radiate vertically polarized radio waves.
I'm going to show you how to assemble a very powerful Wi-Fi gun. And its signal covers hundreds of kilometers. However, the whole construction is light and easy to make. Making a hybrid out of two popular types of antennae, the Yagi antenna and a microchip patch antenna, you can give birth to a real Wi-Fi rifle.
Saying in simple words, collinear antenna is any antenna, omnidirectional simple antenna with something between these quarter wavelength pieces. It can look different ways, something like this, because it's also collinear antennas. It may look many ways, different ways, but it's also collinear. And why? Let's think.
The radiated energy
Let's find out.
can be represented by a traveling waveform
And
of this shape.
theoretical material will help us. Let's
The
listen to some theoretical
waveform normally
information.
follows a sine curve. We will consider one complete cycle of the wave. It is defined as one wavelength. We can relate the wavelength of the radiation to the antenna which produced it. An antenna which accommodates half a wavelength is the simple dipole. If we feed a signal to this antenna, an electron flow will be set up within it. The electron flow first produces a maximum concentration in this direction, reverses, then produces a maximum in the opposite direction. Flow reverses, maximum. This cycle repeats itself at the signal frequency. This electron flow creates a fluctuating magnetic field. Let us relate the direction of this field to the electron flow. As the electron flow reverses, the magnetic field is at a maximum, and the lines of force are in this direction.
That's why we have this thing here. It's purposed to catch and redirect the most powerful radiation in the center of rods of antenna.
When the flow stops, the lines of force collapse. As the flow reverses, the field again reaches a maximum. The lines of force are now in the opposite direction. The magnetic field thus reverses its direction at each half cycle of the signal frequency.
And now we understand why we can see this crown, so-called, in the center of the rod of the antenna. It's redirecting all energy, emitting energy from the most emitting place, from the center of antenna, which is half of the wavelength, and on the quarter of the wavelength it just redirects the energy going up to improve the gain and directional diagram. It's something like this, the same type Wi-Fi antenna. Technically, it can be applied and designed and constructed in many ways, like dipoles or like a circle. I will describe and we'll talk about it later, a bit later. Now enjoy. It's constructed. How can we design it? It's very simple if we take a look. Without formulas, simple way. What we see here? We see a simple rod, length is 1/4 of wavelength. And why it's like that? Because normal antenna has a maximum of potential on upper end and maximum of current of energy on the another end. If it's connected to the ground, it's fine, because we have a receiver here. We receive energy and redirect it and use it as we want. But 1/4 is not enough. We need more. How can we make it higher? Can we make it more? It's simple. What we can do about it? We can take a longer rod. Can we make it longer? Can we elong it? Yes, we can. But what will happen in this case? Normally, maximum flow will be in the middle of it. We have controversial situation on the contrary. We have a maximum of potential and maximum of flow, current flow, in one place. We have very simple situation. And it's what we want, maximum of radiation in the middle of antenna. What shall we do to avoid it? But what if we cheat a little bit and make a 3/4 of wavelength or 15/4? Yeah, we are smart. But there is a trick. Let's think about it. Let's see what happens if we do something like that. Let's imagine we take like half of the way. Okay. We will see the next picture, next situation. In quarter of the wavelength in the rod, according to quarter of the length, everything will be fine. But on the second, current flow, energy will go in opposite direction. Then it's gonna be in right direction like we need, and the next part it's gonna be counterflow. So they will damage each other. So any gain will be not more than 1/4 of wavelength. But how it happens? How we can fight with it? How can we get rid of it? Because this anti-flow, anti-current is killing my brain. How we get rid of it? It's a big issue. How can we get rid of it? What shall we do? Is there any solution? Yes, there is solution. Let's move those parts to the different plane and change polarization. How we do it? Easily. We just make a fucking coils or loops. I don't know how to say in English, it doesn't matter. So what we do? We keep the rod with the right polarization and keep it in phase. And what we do with the different pieces with anti-current go in counter phase, we make a loop to create different polarization, around polarization, so-called magnetic fields, and we solve this issue. So we have this collinear antenna. That's how it works. The more such loops we have, the more parts of rods with right polarization we have, the higher gain. Now what we do? We must connect it with our receiver. And how we do it? We just simply make another loop, so-called quarter of the wavelength ring. That's how we call it. It's a kind of matching device. Can we connect directly? No. Why? Let's think about what we have. We cannot simply connect because we need to connect rod, our antenna, to our receiver in a place where we have maximal current. What if we have not dipole but monopole? Only one vibrator. We must also connect second end of rod. But if we simply connect it, it's not gonna be maximum of current but maximum of potential, electrostatic. What we do? If we have ground, we can connect it to ground. But what if we don't have possibility to ground it? We don't have any ground around because we have other parts of rod longer than quarter of the wave. What we do in such situation? We can make a loop, or we can simply make a kind of metallic magnetic ring. Why we need this magnetic ring? Because it has low impedance, low resistance, and its resistance just like quarter of wavelength resistance. Such Wi-Fi antenna is simply dipole. Technologically, logically, structurally, it's dipole. Also kind of collinear antenna. But instead of dipole, we can use either this magnetic ring, magnetic loop, or simple other loops. Normally it's put on the cable. It doesn't influence on receiving and accepting, but it also can be instead of loops. We have both sides of dipole, but one is only for transmitting, and second, which is in our case magnetic ring, magnetic loop, works as grounding, like in this case. And as simply cargo cooled, it's really working device. It's antennas. Because we need to get electricity, what we do? We can physically move the wire on top as high as we can. It's one way. If we deal with simple AC power, but even AC power, it's not physical moving of some particle electrons from one place to another. We need a gain, we need potential. It's the difference between ground and something on top. More voltage. 1 meter is 200 volts. So what we do? We can go deep in the ground or very, very high in the sky. But I repeat, it's a signal, it's not physical moving, so we don't need physically move wire on top very high away. We need to receive signal from there, because electricity is a signal. Tesla proved it. He turned on many lamps 25 miles around his tower just by sending signal. He didn't put wire to all lights, to all electrical devices. Many devices were working remotely. Edison fan also worked without any wires, with some coils. So there is a way to receive energy without any wires. So we need higher gain, higher potential. So how we do it? We need to receive signal from top. Antenna like this can receive signal from, let's say, and send signal from 100 miles. In this, what we send a small signal and receive feedback. We receive energy from 100 miles. We have potential 100 miles. We can get any amount of electricity, unlimited amount, using such antenna. And I know how to do it. It's very simple. Any engineer now will tell you how to do it. This is simple antenna to receive unlimited amount of free energy. Look at this. 5 levels of resonators, horn antenna, to improve received signal and to send it down. It's a symbol of rotation, and another antenna to receive energy. What we need to send some signal there and get feedback, get it. So now you get the secret of free energy. Think about it, and good luck to everyone.